Okay, so this whole chapter really focuses more so on land rent as opposed to the price that you might pay, which would be the market value. So we're kind of we're showing the relationship between the two, but thinking about how much you're paying per month, per year, per whatever is the idea of an ongoing rent payment. So we came up with this leftover concept where if you're the owner of a land and you're a farmer, one way to think of your profit is whatever went into the land after we take into account other opportunity costs. So we derived the willingness to pay for land that was driven by the quality of the land. So on the productivity of the land, do we have a real fertile soil or not so hot, is going to drive our willingness to pay for land. In the manufacturing section, we did a similar exercise of having the amount driven by distance from the highway. So it was slightly different, but we had the same concept of looking at what's left over, how much can we pay, the WTP here is our willingness to pay for land is ultimately driven by distance with transportation in a manufacturing setting. So we get a good old-fashioned demand curve, but this one's a little different in that we're thinking of distance from the highway, and that's what makes it the bid rent curve, which is slightly different, but it's similar to a demand concept, and in the manufacturing case based on distance. All right, so throughout the city, what drives manufacturing? Why isn't it the center of the city? Could there be agriculture? Should there be housing? All these decisions are kind of location-based decisions. And this is where we left off. Here's where we're going. So these are kind of cool three-dimensional graphs that show how rents change throughout the city. And so it's kind of based on this idea of the central business district, that there's some activity at the center through what we looked at in median location theory, right? So if we look at the center of this piece of land, we see rents going up, partially driven up because the types of activities that might be going on, and that's what we're exploring here. And then this picture is looking at that manufacturing center, and as we think about the city, a lot of cities are set up this way. Kansas City is certainly in that case, where we've got 435 and 635 kind of circling around, and those end up being major ways to utilize. And so we have manufacturing companies that tend to locate close here, and they drive up the rent again around those transportation avenues. And then we got 35 cutting through the city, right? So we've got a piece of land that's carved up by infrastructure. Again, in this case, this is an economic model, so we're kind of thinking about this being, we're kind of making it all nicey-nicey, but as cities develop, this would be the types of things, how we'd see the rent surface looking as we go on. Now, if we combine the two things together, we get this as kind of a common prediction for cities. So we've got rents highest in the central business district where the skyscrapers are, and then we've got these rents being a little bit spiked up around these major freeways.
What is the benefit to the firm that's in the very center of the actual business district? I mean, is it worth that much more to be in the middle?
That's what we're going to look at. Yep. That's exactly the question we're going to try to address, is what drives up the cost so much here? What are the forces behind it?
Why does it plummet in the middle and then it goes back up
here
on the outside? Yeah, why won't that be just straight down?
Probably residential filling in, so that the distance, and it would depend on some things we're not showing here, on whatever the number of manufacturers are, for instance. But If there's fewer manufacturers, then they're all going to be within a mile or so, let's say, right? And if this is 10 miles away, then there's room for rents to fall, maybe even down to a residential level, somewhere in between here, too. Okay? All right, so office firms gather, process, distribute information. So we think about the downtown financial centers. And we've learned about median location. So how is the information business different from agricultural and manufacturing? So if you think about these skyscraper people, they're mostly in the information business. Think about the product that they do. What's important to their business? What's important to their business?
Isn't it the infrastructure for the most part?
Yeah, in what respect? Like as it,
We're
and
talking
then,
about-
and then kind of contrast that to farming or manufacturing. Like, okay, you guys got the idea of Citicorp or something, right? And their 120-story building. I mean, think about their business versus these other. So how's the information business different?
Information, I mean, for the most part, you could consider farming as the more you have in terms of land, the more you can do.
Okay, right.
And-
So the
and
production function's a little
manufacturing,
different.
Yeah, and same with manufacturing, where, you know, the larger space you have, the more ability you have to produce. But in information, you just need a plot of land and the quality of whatever you have on
Okay,
the land.
so information itself doesn't occupy a lot of physical space, right? So that's part of it, both on the input side and the output side. The idea of I'm selling information really doesn't occupy a lot of physical space. So that's kind of weird and a little different as we start to pick this apart. Okay, what else might go on with that business that might be unique to it compared to maybe manufacturing and farming? Or just think about the business itself. What goes on?
Your people aren't very replaceable. Like it's
Okay.
farming and manufacturing, the jobs are not necessarily easy, but
Right.
learnable.
Yes.
Information, selling ideas, that's creativity, that's individuality.
Yeah, so it's a little more specialized, right? So it's definitely a little more of a specialized area. And then what about the relationships between people? If you've got highly specialized people that need to talk to each other, a lot of times there's a need for face-to-face close proximity, right? And so because information doesn't take up a lot of space, it allows us to physically locate close together. So I think of like what I did in the real estate business. I had attorneys, and the attorney was on one side of town, and the architect was on one side of town, and the construction guy and the drywaller and the electrician were on one side of town. And I, as the developer, had to travel sometimes. They would travel to me or I would travel to them to have a meeting or something, right? And so you have a lot of face-to-face contact that goes on too. And so by having us more focused and concentrated into one place, that's less distance. It makes us a little more efficient. If the information, if the final product doesn't take up a lot of space, it might make it more valuable for us to locate there. So here's the model that we set up. Kind of similar to the martini glass and the principle of the median location model, is that if we're right in the middle of the heart of the action, like right in the center of it, then we save on travel distance. So how this model's set up is thinking like we did with principal median location, where we had to take trips back and forth delivering our pizza, and it was best to be right in the middle. So now we've got people that we deal with on a daily basis in our information business, and we're going to travel to each one of those people to do meetings or to work our business. And so the place with the shortest distance to travel is right in the direct center. And then it gets kind of interesting as we move away from the center. And this particular model is not the one I first showed you where it's three-dimensional. We can think a little more 2D with this one. So 0, 1, 2, 3, 1, 2, 3. And as we move away from the central spot, we start tacking on another trip, similar to what we did with the pizza guy, right? And so our travel distance and they've got it set up here as east and west. How much more are we traveling there? We're saving on traveling one direction, but then we're loading it up here, and we get that same result of the principal median theory. So our total travel distance goes up anytime we move away from that center. Okay. So look at the variables here on the axes as always. Location of blocks from the center of where we locate our business. But here we're measuring the distance in the form of trips in a way. And so if I'm 1 block further out, the distance climbs to 26. But if I'm 2 blocks further out, it starts to go up, increasing at an increasing rate. It's not linear.
What does CBD stand for?
Central Business District. So that's the central spot, the big part of our cone. All right, so I threw this question out here. If we got the setup of the downtown business area, and we're all in the information business, and that's the setup. Is this concept here the idea of knowledge spillovers or more direct costs? That we get the distance increasing at an increasing rate. Is it direct, or are we somehow measuring the spillovers, which we did earlier? It's direct, right? So this is just a function of the math. If you move away from the center, your distances go increasing at an increasing rate. And so that's going to affect the costs of your location ultimately. All right, so let's see, I think we just answered that one. All right, face-to-face. So what about office bid rent without factor substitution? This is kind of the simple starting block. What is factor substitution?
Capital and labor.
Capital and labor, good. So we're not going to allow that, so that's again a restriction, and then we're going to loosen that up later. But right now, let's just say we need 80% capital, 20% labor, whatever, and that doesn't change. It doesn't matter on how much what the prices are, whatever, we have to use that. Okay, so without factor substitution, we're going to convert those numbers into what we're willing to pay per hectare ultimately. So here's the land prices. As we move further away, we've got higher and higher travel costs. And so that's going to lower our willingness to pay. Right? So that's our connection to how much we're going to pay per site. You guys see what's going on here? So we build these high skyscrapers on a small piece of land. So if we're only on a 1/4 acre site, we're willing to pay $250. We got $1,000 per acre to just convert that. All right, questions on that one? And again, these are just hypotheticals. We got revenue staying constant and capital costs. The demand is slightly bent. There's really a curve here. We're not just in a line. So why is that?
Because increasing rate travel costs.
Okay, good. Yep, because those travel costs are increasing at an increasing rate, then our willingness to pay our bid rent as we move away falls at an increasing rate. So this is kind of weird that we have thing that, or demand curve that's kind of bowed outward. Now, we're going to use a little bit of terminology with math on convexity and concavity, something that you might have studied a long time ago, or maybe not so long ago, depending on what math class you're in. Is this convex or concave?
Concave.
Concave, right? So anytime I always used to remember that it's like a cave, right? It creates a cave if we do it over the origin. And so we got concave where we have other functions that might be convex. Yes?
Can you just give an example of like travel costs, like how they're increased, like is it, like what costs all in traveling are increasing and increasing?
Yep. Let me back up. You were okay with this graph? Well, this one was really generated from this. Did you get this?
Oh, okay, yeah.
And that's kind of the hook right there, is that because of the median distance theory, if we've got that going on, our distances go up exponentially. Now, even if we have a linear travel cost, like every block cost me $25.
Yeah, I thought it was saying the costs were increasing.
Okay.
Right? So I thought it was saying like.
Well, the costs are, but it's because of this, because the distances are increasing at an increasing rate. And so even if our travel cost is $25 per mile, right, which is linear, whether I go 100 miles, an extra mile is only going to be 25, or if I go 2 miles, an extra mile is going to be 25. The fact that the distances are going up, yeah, got it?
We're talking, the 2 is just the cost per unit mile, correct? In this case?
Yes. No, this is the travel distance on each side, I think.
Those are the number of sides.
Yeah.
It's just they have like
All right, let's see, where are we here? So, capital land are input substitutes. What if capital improvements in land could now be substituted? What would happen to our buildings?
They would locate next to each other?
Yes, they go together with each other.
Right.
So what's the composition of the land and the buildings? They go, so better be careful here. There's an erection going on, right? Buildings now, of course.
Well,
You guys keep your mind out of the gutter.
They erected steel outside.
That's right. We
proper
saw
term. It's the
some
proper
erections
term.
going on over here. Hopefully, we'll see a lot more outside for our building for the new student place. I heard that is there was a steel delay, which I
It's
faced.
about
I faced
3 months behind.
I
Right now.
faced steel delays just like that when I was putting up buildings that
Oh,
had
really?
a lot of
Behind.
steel,
About
and that can be mind numbing on how.
So they're gonna be working day
the
and night.
current.
Yeah, they're gonna have to push hard, but
projected day is like late July right now.
is that where they're at?
Yeah.
Okay. So yeah, they can hopefully make up some time in some places, but not
They were
everywhere.
planning on having it done by early spring break because they were ahead of schedule towards the beginning of the year.
So here's a new one that you guys probably didn't know.
It's,
Buildings per square foot are a lot more expensive when you go vertical. So according to building code, you can stay in stick frame construction at 3 stories. And sometimes you can cheat a little bit and have 3.5 stories with little dormers. Now I'm talking about building code. Technically you could go with wood higher, but when I developed apartment buildings, I did mid-rise and so we pretty much stuck to 3-story buildings because that's all allowed, and that's the cheapest way to go, is to stay in stick frame. When you start to go higher, you got to get into reinforced steel and metal studs and concrete. And so the cost per square foot starts to go up. So with the short building here, and this is just hypothetical, they've got capital cost of 50, 100, and 250. 25-story building, a 4-story building, a 1-story building. And once you get into 3 stories, you start getting into elevators, right? And that adds costs. So these are all things. One elevator that runs just 3 floors can be, it's usually $10,000 a floor, but on a 3-story, and this was when I was, within the last 3 to 5 years, I don't know if it's gone up or down, that would have been here at Ottawa for the last 3 years, but 10,000 a story was roughly right. But on a 3-story building, you'd probably have to spend 50,000 just in the elevator alone. And then you got to create the shaft. The shaft has to have 4-hour fire protection, so you're usually putting 2 sheets of 5/8 inch drywall instead of 1. And so there's a lot of other additional requirements that go on when you build bigger buildings.
So in Bennett Hall, they spent probably 30,000 on that elevator for 3 floors.
I hope not.
Is it real slow?
It's real slow.
So it's a hydraulic elevator, and hydraulics are cheaper, so that would be the one to put in usually for most 3-story buildings. When you start to get into taller ones, then those are cable driven, and the cables make it. And then there's some other technology too. We got totally hosed on a elevator deal that I'll tell you about some other time. But that delayed that project. So that's the gist of this switch. So remember ISO quants? Oh boy, I heard a, oh boy, here we go. Capital, labor, capital, we had capital and labor normally, but now we got land here. So same type of trade-off is capturing that table that we just did. So as we give up land, we can substitute it with bigger buildings, but those bigger buildings are going to cost more money, right? And as we squeeze down to a real tall building, we can put a lot of people in it, but per square foot, that's going to, go up in price. So we end up getting this type of look.
Have a longer salvage value than shorter buildings? Is there any way to compare them?
Well, there's higher maintenance costs. In theory, I'd like to think they're going to last forever, but then they blew up the concrete dormitories at ISU, which was awesome. We were on top of our new building that we just built and watched them come down. But when they built those back in the 1970s, they thought, oh, this is like building the Coliseum. It's going to be here for 100 years. Well, 30 years later, they're putting dynamite in them because they were starting to fail, and it turned out the cost of fixing them was higher than it was worth. All right, I think we'll probably hit there. Yeah, that looks like a good spot.
So you want us to all stick around now to talk about?
Whenever you want. I got time right now.
I just have 2 of the quick ones,
Okay.
and one we all had the question on.
I will. Those ones that we talked about with the slope, I'll look at all your exams for that. That's not that hard. So if you have a different one, yeah, anytime. You had a different one too, Adam? Where did I
It was
put
the
those?
one with the lovely bread, and I just counted to figure out the lines on how long.
Oh, yeah.
That's why I put the 2 8, so it was easy to count to the 8.
Yeah, you had a pretty picture in it. So that is the furthest.
So,
World conversation, I didn't use the
No, I'm with you there. All I would have liked you to do is explain exactly what you're doing. Like, if I go one more over, I get one more. I don't think so. Kind of explain that. I know it's asking golf as opposed to.
that's not a good sign.
Right.
No,
Okay.
It'll go back down as fast as it came back up.
Wheat's going up though too.
Hey Russ, I won't be in class on Thursday. I got a senior core board.
Okay.
But then I'm good for the rest of the semester.
Okay, cool.